Are there any questions though? I know someone asked also like about using the factor label method. Again, I wasn't trying to dismiss anyone's question. It's just, for the proportions, that's what I did for these problems. I just thought more people understand. So wasn't trying to dismiss anyone's questions. I hope it didn't come off that way. All right. So I have one more problem I want to do. The last one I was going to put on a quiz. I was a little concerned it'd be too tricky, but I figured let's do one. Let's do it in class then. So, and as a reminder, this conversion here, it's in the textbook. So of course you don't have to memorize it. I mean, I can't memorize these, conversions. But these are all, I guess, by definition, you can say. Okay. Is that liters? Like the 1 gallon and liters, right? That's down here. That's given. And that's how I forgot which one. I think I used the first one. That's how I was able to get the first unit conversion. All right. So for the next problem, we want to convert 75 feet per hour to meters per second. So we want to convert 75 feet per hour to meters per second. And it's really just like the second problem we did with the euros and the liters and gallons, I mean. Basically, we're going to go from feet to meters, and then we're going to go from hours to seconds. So what I'm going to do is I'm going to handle the numerators first. That's actually a little bit easier, although the denominators aren't terrible. For feet to meters, notice here we have this, right? So we can use either one of these unit conversions as either one of these ratios, excuse me. Right? Basically what we want is we want to fill in this blank. Okay? Okay. Now, this blank, again, the unknown, I'm going to call it x instead. So x is how many meters there are in 75 feet. And again, we get a ratio there, right? One ratio we get with unknown information. So we do 75 feet over x meters. Okay, but again, going back here, we have feet over meters, right? From here, we can use the first ratio here. We have feet over meters, right? So this would be the ratio with known information. And just like before with these ratios, we make a proportion, right? They're equal, like so. Again, the same units in, the units in corresponding positions, right? And then what happens, just like before, we cancel the units, right? Foot and feet cancel. Same thing with meters and meters cancel. We get this proportion on the right. And remember, we're going to cross multiply because we want to know what x is, okay? So we cross multiply, get x times 1 times x on the left, 75 times 0.3048 on the right. And so then you just do the calculation. You get x is 22.86. So 75 feet is 22.86 meters. Okay, that's good. Now for the denominators, right? Well, again, we want to know 1 hour is how many seconds. That's what we want to know. Okay, so this one, there's a subtlety I did, but I'll explain it. 1 hour is how many seconds? Okay, so I'm going to call this blank x, right? So let's let x be how many seconds there are in 1 hour. So we have a ratio, 1 hour over X seconds. Okay. Now, what do we know? Well, we know 1 hour is 60 minutes, right? We know 1 minute is 60 seconds. So we could form this ratio. And then if we try to make a proportion with this, 1 minute is 60 seconds, this is not going to help us, is it? I mean, the denominators, we have seconds. Here we have hour and minute. Well, hour and minute are not the same thing. What can we do? Well, the answer is down here, actually. We also know 1 hour is 60 minutes. So if I substitute like so, then we have a ratio we can work with. Okay, so let me go through it again. We know 1 hour, we want to know how many seconds are in an hour. So in other words, we want to fill in this blank. So X is how many seconds there are in an hour. I'm calling that blank X, so to say. And I make this ratio. We also know 1 minute is 60 seconds, or 60 seconds is a minute. Maybe that's better. And I got this ratio. Seconds in the bottom, the denominators. But again, this proportion alone isn't helpful because we have hour here in the numerator, minute here in the numerator. I mean, we have seconds in the denominators, that's good. But what we also know is 1 hour is 60 minutes. And I'm using this because we want the same unit in corresponding position. So we have minutes and minute, that's the same basically here. And here we have seconds and seconds. So now we're good. Now we're going to be able to cancel. And that's the next step. Are there any questions how I got this? Well, that's really the hard part because now, again, once you get the proportion with the correct units, then we're home free because now minutes here and here, those cancel. Even though this is plural, this is singular, that is here we have minutes. We have the S here. Here there's no S. We can still regard them as the same. I mean, hour and minute, they're not the same. So seconds and seconds are the same. So from here, we get this proportion. And then cross multiply. So what do we get? We get X times 1 equals 60 times 60. I wrote it this way, but again, equality means the left and right are the same. And you can interchange both sides if you want. So we have X equals 60 times 60, which is 3,600. So 1 hour is 3,600 seconds. That's what we get. So again, I got this proportion. Once we got here, we just solve it like we did with the other problems. Units cancel, cross multiply, and then we get X. And once we know what 1 hour is, which is 3,600 seconds, we substitute, right? We got 75 feet. We got where is that? 22.86 meters, right? We just got 1 hour to be 3,600 seconds. So we have meters per second. But again, I want to round this. And not round, excuse me, I want to divide. Okay. And when you actually divide, you're going to get this number. Okay. And that's the answer here. Again, this one was supposed to be on the quiz, but I thought this would be like too tricky for the quiz, so I took it off. So, what questions do you have about this? Okay. So that's basically it for chapter 2. Okay, let me see. We have about a minute left. Let me see if I could briefly start chapter 3, at least introduce it. I can update chapter 3. No. Just want to get chapter 3 going very quickly. Chapter 3, we look a little bit into functions. Basically, here we're going to see what mostly a linear function is. We're going to see what a linear function is. I mean, here actually we're going to look at what functions are. We're also going to see function notation and different ways that mathematicians represent functions. You know, different ways they do it. We're also going to see, in particular, a linear function. Now, I don't know if anyone here has had me for Math 104 or has taken Math 104. The approach here is going to be a little bit different. Just letting you know. But that's what we're going to see here, though. Functions, okay? So basically, I mean, functions are going to come about. You know what? We're out of time. I got to stop, actually.